Alright, we're going to do number 1 from this tree diagram exercises. The directions at the top say follow examples in the notes in our previous work. Complete the work neatly on a separate sheet of lined paper. So I have a separate sheet of lined paper ready to go. Problem number 1 says 2 fair dice, each having faces numbered 1, 1, 2, 2, 2, and 3, instead of the normal 1, 2, 3, 4, 5, 6, are thrown. Draw up a probability tree for the scenario. Find the probability that the total score is 4. For part B, the total score is less than 4. Part C, the total score exceeds 4. And D, at least one of the dice shows a 2. All right, 2 fair dice. So that means that it's not weighted. It's not possibly going to fall on one side more than another. But there are only 3 different faces that could come up. We could have 1, 2 possibilities to get a 1. We could have a 2, there are 3 2s, or we could get a 3. So in our first toss, we have 3 options. It's going to land on 1, 2, or 3. So I'm going to branch off here in 3 options, 1, 2, or 3. You could either get a 1, a 2, or a 3. Now, in order for them to be equal probabilities, there would have to be the same number of 1s, 2s, and 3s, but there's not. There's 2 1s, 3 2s, and 1 3. So there are still 6 total sides. Notice there are only 2 1s out of those 6 total sides. 2 divided by 6, what is that as a probability? 2 divided by 6. That's 0.33333, 1/3. So the probability of getting a 1 on the first toss is a 0.333. Remember, I'm using 3 significant figures here. The probability of getting a 2, we've got 3 2s out of 6 total sides it could land on. 3 divided by 6 is just 1/2, so we got 0.5 probability of landing a 2. Again, there are 3 2s out of 6 total sides. 0.5. The 3 here, there's only 1 3 out of the 6 sides, so we're going to do 1 divided by 6 to get the other probability. 0.166666. I want 3 significant figures, so 0.16, and then that next 6 will round up because of the 6 after it. So 0.167 is the probability of getting a 3. Now this is just, label this is the first dice. All right. Now, for each one of those dice, there's still the probability that when you throw the next one, or that the next dice could also land on a 1, a 2, or a 3. So again, we're going to branch out 1, 2, or 3. We could get a 1, a 2, or a 3. If you roll a 2, you could still get a 1, a 2, or a 3. And if you roll a 3, you can get a 1, a 2, or a 3 on the second dice. This is second dice. Okay. All right. And each time, because we're talking about the same type of dice, each having faces numbered 1, 1, 2, 2, 2, 3, the probabilities are the same for the 1, the 2, and the 3. To get a 1, it's 0.333. Every time, 0.333 for this one, and 0.333 for getting a 1 here. For getting a 2, it's 0.5. I'll fill those in for the 2s, 0.5, 0.5, 0.5. To get a 3, the probability is 0.167, so I'll fill those in. 0.167 and 0.167. Again, we're just labeling the branches with the probability of that individual event happening. All right. The next step is to find the probabilities of those different events. Or I should say, of those different sets of events. So the probability of getting a 1 and then another 1, we multiply the corresponding branches. So we got 0.333 times 0.333. So what is it? That's 0.333 squared. 0.333 squared. 0.1108, three significant figures. I'll go 0.11. That's going to round up to a 1. Probability of getting a 1 and then a 2, 0.333 times 0.5. 0.16, that 6 will round up, so 0.167. A 1 and a 3, 0.333 times 0.167. 0.056. 0.5 times 0.333. I've already actually done that. Same thing as here, 0.167. When you multiply, the order doesn't matter. So 0.5 times 0.5, 0.5 squared, 0.25. 0.5 times 0.167 is 0.0835. I'm going to keep all those numbers because I only have 8, the 3, and the 5 as significant figures. And now 0.167 times 0.333. I think I already did that. Yeah, I did it up here. I got 0.056. 0.167 times 0.5. I already did that here for 0.0835. And the probability of 3 and another 3, that's 0.167 squared, 0.0279. Alright, now I can actually answer the questions. The probability that the total score is a 4. It might be helpful to just do another column here of what the totals are. Totals meaning score being like the 1 and the 1, they add up to a 2. So the probability of scoring a 2 like that is 0.111. Okay, 1 and 2 here, add those up to 3. 1 and 3, add up to 4. 2 and a 1, add up to 3. 2 and 2, add up to 4. 2 and 3, give you 5. 3 and 1, give you 4. 3 and 2, give you 5. 3 and 3, give you 6. Okay. Total score being 4. So there are I see 1, 2, 3 different ways where we could, I see 1, 2, 3 different ways that we could possibly get a 4. So we're going to add up the probabilities of those. It's like the probability of getting it this way, or this way, or this way. So we just add up the probabilities. I got 0.056, it's coming from right here, plus 0.25, plus 0.056. And so for A, our answer is 0.362. The answer in here. This is problem number 1. Label that. Part A, 0.362. All right, B. The total score is less than 4. So I've got all the 2's and 3's that are totaled. Total of 2, that's 0.11. This 3 adds in 0.167. This 3 adds in another 0.167. That 2, that 3, that 3. All the other ones are more. So add those together. We've got 0.445. The total score exceeding 4, so being either 5 or 6. The 5s, I've got this one here, 0.0835 for that probability. And again, so how about this? Do a little trick, times 2. And then add in the probability of getting a 6, which is plus 0.0279. 0.1949. I'll round that off to 195. 0.195. Alright, and D, at least one of the dice showing a 2. Well, let's see. Here, if I roll 1 and a 2, that's 0.167. Showing you 2. 2 and a 1 gives me 0.167 again. 2 and a 2 gives me 0.25. 2 and a 3 gives me 0.0835. And a 3 and a 2 again here gives me another 0.0835. Adding all those up, got a 0.751 probability, 75%, pretty likely. All right, you can continue on to finish the rest of the problems. Again, the front side is homework to be finished by Monday. Good luck.